So today we're going to look through the topics of classes and objects. So let's start. First, before going to the topic of classes and objects, let's talk about object-oriented programming. In Python, if you have experience with, when you write code, you just write it like a procedure. It's called procedural programming when you write from top to the bottom. And your code also works the same way. So it starts running from the top and until the end of the bottom of the code that you have written. But Java works a bit different. Like it works in object-oriented form. Like you cannot write the same as you write in Python in Java. So then what's object-oriented programming? In procedural programming, you work with variables and you work with functions. And it might get a bit messy sometimes. And object-oriented programming is when there's a connection between objects. So you create the object and you work with them, and they have like their own attributes and methods, and it's a lot secure compared to procedural programming. As we look through these topics from today on, you will understand deeper what I mean by like integration between different objects. So what is class and what is object? Class is just like a blueprint. It's just a sketch or plan of something. Let's say a house. And the object is an instance, or that house, a real house that is built using the sketch, like using the class. So class is a blueprint, object is an instance of that blueprint. Yeah, that's it. And classes, they are object descriptor, defines the common structure of a set of objects. Yeah, and our class consists of attributes, methods, and constructors. Attributes are the things that our class contains. For example, we have a class student. And what student can have? They can have a name, they can have age, they can have their own classes, like classes they attend, modules, I mean, like they can attend mathematics class, they can attend literature class, like that. And methods are the actions that they can do, like they can read, they can write, like they can attend the lesson or they can skip the lesson, like so. And constructors, we will talk about constructors later on. Mainly you have to here understand the attribute and methods. Yeah, and here is how in real life it can look like. So in this square, you can see a class definition, or like how a class can look like. Car is the name of our class. Color, brand, and turn on are its attributes, and turn on, paint, and print state are its methods. In code, this would look like this. Here, first we are setting, we are setting its scope, public. It can also be private, or it can also be protected. And then the keyword class, and then name of our class. For example, here the name of our class is car, but you can name it whatever you want. Like there are no like certain rules to name your class something, but it should be more readable and human friendly. And these are its attributes. Like what can car have? It can have its color, brand, and Boolean type value turned on, like if whether it's turned on or turned off. And we have here its methods. So void methods doesn't return anything. So here we are just setting the attribute that our car class had to the true value. it was a boolean, so when turning on, we are setting it to true. And we have another method called paint, and it takes a parameter new color. And whenever we call the paint method of our car class, it will just paint our car. Doesn't actually paint, it will just set the color attribute to the value that was given as an argument. So here we're taking the new color, and when we call the paint, we are setting the here color attribute to the new color we took here. And then we have one more method that is called print state, and it will just print out the car as a string and its brand here. Where was it? And then its color, and the color was here. And then plus turned on. Here it's like a if statement, a shorter form. Turned on, we had a turned on attribute, and it had a value type of boolean. So if it's true, it will print out on. If not, it will print off. Here we haven't called the method yet, but if we call the turn on, and it will be equalized, turned on will be equalized to true. So the engine is on will be written if the turned on equal to the value of true. And methods. Methods represent the messages that an object can accept. Yeah. Here, these are the methods, and we had turn on, paint, and print state methods in the example above. And they can accept arguments, like here. We could accept the argument for the new color parameter. Yeah. And that's just how we call the function. It's not a function, it's a method name, and then braces and the list or the list of parameters or just a parameter that it asked for. That's how we call it. But before the method, we should have our instance to call the method for. Yeah. Overloading. Before moving to the topic of overloading, let's talk about polymorphism, because overloading is just one part of the polymorphism. Polymorphism is the principle of OOP. We have talked about OOP, object-oriented programming, and it has its 4 principles: polymorphism, encapsulation, abstraction, and inheritance. So polymorphism is one of them, and overloading is part of the polymorphism. What is actually polymorphism really is? Polymorphism is the principle of OOP that gives the object the ability to act differently depending on what class it's working with, class object it's working with, or what parameters are given when working with the method. So it gives the ability to the objects when we call different methods to act differently depending on either the class or the parameters. And the overloading is about the parameters that we give. So here, if you remember, we had the paint method, and it was taking one parameter, right? New color. And we were setting the color to the new color. And overloading, a class may define different methods with the same name. Like in overloading, in our class here, we could have the paint method one more time, but with different parameters that it could take. In Python, if you have like experience with Python, you might have different understanding, because the last method defined with the same name will be saved, because they are saved inside a dictionary. So the last one wins, and it will be the one that is saved. But it's not the same in Java, so we can have different methods with the same namespace. So we can have 5 or 10 or hundreds of paint methods inside just one car class. So it's overloading is which method, like among those hundreds of paint methods, can work when we are calling the method. So this is overloading. So they must have distinct signature. Signature is their parameters. A signature consists of method name, yep, and then ordered list of argument types. And methods whose argument types least match the actual parameters is selected. Here in the example, you can understand it more fully. So we have the class car. We don't have here anything public, private, or protected. Just don't care about the scope yet. If it's like not written, that means it's just public. And we have the here parameter string color. And we have, as you see, 3 paint classes, and then all can work simultaneously. So all are saved inside our car class. And when we call our, oops, let me here, yeah. And when we call our paint function, it will work depending on what type of attribute we are giving. So as you see here, we have 3 paint methods, and the difference is in the parameters that they are taking. First one doesn't take anything, second one takes integer value, and the third one takes a string value. So let's say it's actually when we define instances, they will not be written here, but for just an example, I'm writing it here. Let's say we had car instance. Don't care about the syntax yet. Here I have just defined a object C here. And let's say we are calling the paint method. And as you see, I'm calling it without any argument. So it will just go to the class and it will search for the paint method. Here, it matches the parameter. This one doesn't take anything, and we are calling it without giving any argument. So it will match with this one, and it will set the color to the white. We had the attribute string color, and now it's equal to what? White. But if we call it with an integer value, let's say with 5, and this was null. So we are calling it with an integer value. It will go and look through the paint called methods. This one takes 0 arguments, so it doesn't match. And this one is taking what? Integer value. And inside our scope, there is nothing. It's just null. So if we call this, nothing happens. String color will still be null because there's nothing inside our method. So this was the second, and we can call it with a string value. It will again go for the car class because we are working with what? Object C. Object C is type car. It will go to the car class and it will search the paint methods. Here we have it. Is it taking the string parameter? No, it doesn't. It doesn't take anything. What about this one? It's taking integer, but we are looking for the string. And this one, yeah, this one does match because we are giving string, and this also takes a string parameter. And what is it going to do is it's equalizing this color attribute here to the new color argument that we are giving. So now when we call it like so, the color will be red. That's how our loading works. basically. Yeah. Example, we have a class called foo, and it has a methods do it with the same namespace, but the arguments, but the parameters that they are requiring are different. First do it requires integer parameters first and then the long parameter second. But the next one requires the long parameters first and then the C parameter with the type of integer. So the difference is the order of the parameters that it's requiring. If it matches the first one, it will print the letter A. If it matches the second one, it will print the B. And here we created an instance for the foo class that's called F. Object name is F. And then we are calling the doIt function. First, we have 5 given as an argument, and then the next argument is long with the value of 7. So which one is it matching? First, it's integer, and the second has the long value. So it's doIt methods here. We have here 2 doIt methods, and first argument is integer, this one, and then the second is the long. So it's matching the first doIt method. So what should it do? It will print ln as out print ln a. So it will just print the letter a. And then the second time when we are calling the doIt method, first we are giving long typed argument 5, and then we are giving integer typed argument 7. And it just goes again here, doIt, and here the second doIt, and its first parameter should be long, which matches this one, and the second is the integer. It's again matching this one. So this method will work, and it will system out println B. It will print the letter B, and here the return value, how is it going to be? Yeah, that's it. So basically overloading is when we are calling the methods, it's acting differently depending on the list of arguments or the order of the list of arguments it's taking. And now talk about objects. An object is identified by class, just like this here. This is an object F, and we are defining it by its class. Class is foo. Here is the foo class. It has its state, values of attributes, and then its internal unique identifier. 0, 1, or more references can point to the same object, which is called aliasing. Let's look what aliasing is. Here we have an example of aliasing. We again are working with our beloved car class. So it has attribute color and method paint, and then again one more method paint. And here we are creating 2 variables, A1 and A2, but we haven't given a value for them. We have just A1 and A2 in the memory, but they don't have any type yet. And we are setting the A1. We are referring to the A1 as an instance of the car class. So we're basically saying that A1 is a new instance of the car class. Yeah, and now it will have the attributes and methods of the car class, but before that, which is here, it couldn't have that. Here, without writing this one, we cannot say A1.paint green. Even if we are saying its type is car, it doesn't have its attributes and classes taken to the A1 and A2 yet. So we should initialize our object first before using its methods, before calling its methods and attributes. So now we are painting it to the green. Here again, overloading works, and we are giving argument green, which is here with the parameter string. So now color will be equal to what? Green. So A1's color is green. And we're saying A2 equal to new color. And now A2 is initialized as a car object. Here. Two uninitialized references. Just look at the first line. Two uninitialized references are created. They cannot be used in any way. A reference is not an object. This is just a reference. We just create them in our memory, but they don't have been initialized yet. They're just namespaces here. But here we are initializing the A1 as a car object. Object is created and the pointer stored into the reference one. So here we define it. In the first example, we define two references, and here object created. So we had car class, and we said that our A1 is an example of the car class. But A2 here is still null. It doesn't have any value yet inside. And now we are painting this this object, which is A1, which is an instance of the car class, to the yellow. Method paint is invoked on the object through the reference A1. So we are saying that A1.paint yellow. And here, now we are saying A2 will be equal to A1. A1 was equal to what? A1 was equal to it was an object of the car class, and it had a color attribute that is equal to the yellow. And now we are saying A2 will be equal to A1. So A2 will have everything that A1 has. And this is called aliasing. So two references point to the same object. We created an object here, and we're just saying that A2 will be just the same as A1. Yeah. But now here we are setting the value of A1 equal to null. We still have our object created here because it has one reference. A2 was also equal to the same thing. So here it means that A1 will be null. Now this thing will be removed and A1 will just be just like this when we created it here. But A2 will still have the values of the A2 that A1 had before it was null. So if we call here, let's say if we say system out println A2.color, it will print the yellow. Even though A1 doesn't have anything inside, A2 still has it. That's the difference between Python and Java. If you do the same thing in Python, the values of A1 is changed, and A2 is referencing to A1, so A2 will be also changed, but it's not the same in Java. If we equalize A2 also equal to the null, and then A2 will be null. And then this will be removed, and then this will not have any reference. So just garbage collection works, and this will be removed from our memory. Yeah. Let's look through 2 more slides and we'll move to implementation, more like practice. Object creation. Object is created with the keyword new. It returns a reference to the piece of a memory containing the created object. Here, we had a class motorcycle, and we are creating an object called M with the keyword new that is inheriting from the motorcycle car class, I mean. About the keyword